Hey, what's up, guys? I hope you guys are doing good. I hope you guys are doing well. So, I just wanted to kind of take this time to explain this jumble of a circuit I built. Um, it's so as you guys saw the video, probably it's a light sensitivity detector, right? Depending on how intense the light is, it'll do three different things, indicated by the LED turning in three different colors, right? Let's get to it. So this was really inspired by a very old school circuit that I'm sure you guys all built back in the day, uh, ninth grade, 10th grade, something like that, right? So source of the power supply, a photocell. This is my photocell right here, right? I have lights going in, here. The photocell is connected to an LED, right? You got your anode, you got your anode, you got your positive right here, right? The anode, that's your cathode, the negative, and the negative is going to go to ground, right? Before that, we're going to hook it up to a current limiting resistor, something small. It doesn't have to be heavy. 100 ohms will suffice. I used to have you guys use 510 ohms, and then we're basically gonna go to ground, right? We're gonna go to ground. Boom. That's it. This is 9 volts. This is my photocell, photoresistor, whatever you want to call it. My LED. The idea is as the light shines on the photocell, the LED is bright. As the light diminishes, like you cover your photocell with your thumb or something like that, the LED will get dimmer and eventually turn off or whatever it is, right? This is your circuit. Now, uh, when I used an Arduino kit, it's pretty cool. It came with the RGB LED, right? It came with the RGB LED. Oops, how do I erase that? Let's erase that. Boom, boom. Came with the RGB LED, right? So RGB has mad pins in it. It's not your LED. LED has only 2 pins, right? This bad boy has several pins. You got the red pin, you have the green pin, and you have the blue pin, right? And of course, what about the cathode? Every LED has a cathode, right? So you have the ground pin. So it has 4 pins altogether. Boom, boom, boom. 1, 2, 3, and then the ground pin is the 4th pin. Now, connecting this up, well, how do we connect this up? What do we do? Very similar to this guy right here, the traditional LED. Let's draw it up here, okay? I'm gonna do my best. Not the best artiste, as you guys already know that. All right. This is one LED. This is my other LED. All right. And this is my third LED. Wow, they all have different looks, different personalities. You see that? They're all unique. Alright, so I got these are all my LEDs, right? These are all my LEDs. Let's say this is my red. Let's say this is my red LED. Oh, hey, let's use a red pen, huh? Let's say this is my red LED. Is this good? Is this helpful at all? I hope this works out for you guys. And then I have my green LED, right? G. This is my green LED. What color is green? Right. And then I have my blue LED. My blue LED is right here. Right? And blue LED will fill this up with blue. Boom. Those are my 3 LEDs, right? RGB. So as I was saying, um, the the RGB LED has basically three colors, right? So three LEDs in one. But my red LED stopped working. My red LED and the RGB LED stopped functioning. Hence, I ended up using this red LED right here. Um, Guess why my red LED and the RGB stopped functioning? Give you $1 if you get it right. Alright, moving on. So, RGB, three different colors, meaning three different levels, three different stages. I figured why not have fun with it and try to program each stage to be triggered under a certain given condition, right? So I have a photocell here. What can I do? How can I use a photocell to trigger each separate stage? Um, so this is where microcontrollers come in, right? This is where things get real fun. This is your microcontroller right here. This little chip and this entire big red board. That's your main chip. Now, what's fun about microcontrollers is that you can program them, right? It's just a regular IC chip. Nothing fancy or special. A little fancy and special because you can program them, code them, and you can code them. It can store data. It can store your code, run your code continuously as long as you're providing power, right? Power is coming from this guy right here. This guy. Can I underline this? Yep. Circling this guy right here. That red cable, right? That's connected to your computer, your laptop. And the code will keep running. Alright. So that's pretty cool. The microcontrollers are basically IC chips that you guys can program, and that's what I did here. Alright, so let's discuss the inputs and outputs here. You remember that I gave you an assignment. Oh, I messed up. Sorry. Let me go back. You guys remember I gave you an assignment about ICs, right? Where basically you had to tell me which pin was the input, which pin was the output for an IC. And you had encoders, decoders, multiplexers, adders, and blah blah blah. And you had to tell me the inputs and outputs. So the microcontroller, right? The microcontroller is the same. This microcontroller has analog pins, which is so sick. You can use analog devices as triggers, right? Like a potentiometer of something that goes up in a range that doesn't have two stages like an LED on and off, right? And it has digital pins. So a microcontroller has analog pins and a digital pin. Of course, they also have a voltage source and they also have ground and all that stuff. But our focus is going to be in the analog pins and the digital pins. We're going to be using both for this particular circuit right here. So I adjusted a couple of things, right? You guys can see I removed that the single LED circuit, and now we're gonna focus on this RGB. Everything is basically stemming from this RGB circuit that we have here. So it's not connected yet. It's just LEDs, right? There's no power going to it. There's not going to ground, nothing of that sort. So let's take care of that. So if you see here, um, this guy right here, this, oh, bad one, that's not good. Let's do this. Let's use the red one, or let's use this one. If you look at this resistor right here, right, this is the current limiting resistor for my RGB crew. I should really technically use three, one for each LED, but I was being a little lazy and I just ended up using one, right? So this resistor um, is about 330 ohms. And what I'm doing with it is connecting it to my cathodes of each LED. Alright? Keep in mind, there's only one cathode pin. So this is your RGB. This is your, what do you call it? Look for an RGB. This is what it looks like. You know what? Scratch that. You have your one pin, R, G, right? And then the third pin is your long pin. This is your cathode. Alright, that's your negative. That's your negative. And then you have the third color pin. This would be your R, this would be your G, and this would be your B. So it has 4 pins. Keep in mind, right? But the fourth pin, or the third pin in this case rather, is your cathode. So that's what's going to this resistor right here. That's the pin that's connected to this 330 ohm resistor. And the 330 ohm is going to ground. This is represented by the black wire. So the 330 ohms is going to ground. And that's that black wire right here. That's not a good look. Let me change it. You know what? Let's undo that. Alright. Alright, so now this black wire right here, this is your ground. That's my ground. That's what I have done here. This is the ground. Alright, what's next? So next is the anodes. Where are these anodes going to be connected to? Can you guys tell me that? And how many anodes are there? How many anodes are there? Can you guys tell me that? And let's move this out of the way. Alright, I hope that's not bothering anybody. Okay. How many anodes are there? And are they analog or digital? Analog or digital? Think about it. Okay. So we have three anodes, right? Red, green, and blue. And each of these anodes are going to go to a separate pin. Alright, so there's a pin for red. So I'm going to draw a red line here, and I'm going to draw a red box. I'm going to draw a red box. And the red pin is going to go to pin 13. It's going to pin 13, which the red wire here you will see is going to pin 13. Then I have my green LED, right? The green LED is going to be indicated by a green pin, and the green LED is going to pin, can you guys guess? Pin 11. Finally, my blue LED, alright, my blue LED is also going to a pin. Again, these are digital pins, alright? These are digital outputs. My blue LED is going to pin 12. Yep, I want to pin 12. So let's get the photocell connected. We got the RGB going on, right? Let's get the photocell in the mix as well. So let's get to it. Before I do that, I just want to kind of remind you guys, well, not remind you guys, but bring this up. You see a push button here. This push button, it doesn't really belong in the circuit. I used this push button in a previous circuit just to get my hands dirty a little bit. So this doesn't really belong here, so I'm just going to black it out. You guys can ignore this push button altogether. Alright, it's not part of the circuit at all. Alright, let's get to it. Let's do the photocell. Alright, let's do the photocell. And the photocell, I'm going to circle in yellow because it has a yellow wire to it. Alright, and if you notice, it's connected to a a red wire right here, right? This red wire right here. This red wire is connected to the photocell. This red wire is also connected to 5 volts on the red board, the voltage source on the red board, on the red board. Sorry. So let's get to it. So I have my 5 volts power supply. All right. This battery right here, 5 volts. That's going to this photocell. All right. This photocell. This photocell now is going to an interesting place. It's going to what we call a analog pin. All right, an analog pin. This analog pin is on the red board. This analog pin is actually an input. Right? It's going to pin A0. A0. All right, so this is going to be pin A0, and this is the output of the photocell. A is for obviously analog. Alright, you guys guessed it probably. And it's pin 0. Z-E-R-O. Okay. Let's get to it. Now, you will see a resistor here. This resistor right here. In yellow again. This resistor did not need to be there, but I connected it. I'm not sure what I was thinking, but I connected it. And that resistor serves the same purpose as the resistor connected to the cathodes in the LED. It's basically a current limiting resistor, and this resistor is 330 ohms. Alright, my voltage source is 5 volts. Alright, this is my plus. Now this guy is going to ground as well internally. Now this ground is connected internally. This part is connected internally. It's not here. It's part of the red board. Alright, you know what? I'm going to undo that part because that might confuse you guys. Okay. So this is my circuit. Alright, that's basically it. You see the anodes. There are 3 anodes. They're going to the outputs, digital outputs. These are all digital, by the way. These are all digital outputs. Okay. These are digital output pins. Right here in pin 11, 12, 13, digital output pins. This is pin A0, analog pin A0, which is right here. The circle right here. Alright, analog A pin. Analog pin A0 is going to the photocell. Alright, that's basically my circuit. I know this might look a little confusing to you guys because usually we have everything connected, all the loads and one power supply, one ground. But this is how we use a Arduino kit with a microcontroller, and this is how we will connect it on the breadboard if we want to program each individual pin to function based on the photocell. Alright, I hope that helped. If you guys have more questions, feel free to ask me, message me, chat me, whatever. You know how it is. Guys, stay safe, be well. I miss you guys. Wish you the best. Let me know if you need anything else. Bye bye.